Okay, when we are converting from a polar equations, which have r's and thetas, to a rectangular equation, which has x's and y's, we're looking to find three things. Okay, if we could find an r squared, that would allow us to replace r squared with x squared plus y squared. Okay, the Pythagorean relationship between the radius and the side lengths. If we could make an r cosine of theta, we could replace that with just the letter x. Or if we could make in our problem an r sine, then we could replace that with y. So when we're converting, we're really looking to do some substitution. Okay, but we can only substitute specific things. We have to substitute an r squared, or an r cosine, or an r sine. So we're going to do our best in these problems to make those things happen so that we can do our substitution. Okay, so in this first problem A, notice it has r equals root 5. So we could do a couple things. We could multiply it by cosine, and that would give us r cosine. Or we could multiply it by sine, and that would give us r sine. But then we'd have something on the other side that was not nice. So let's, in fact, just go ahead and square this to give us r squared. R squared equals 5 when we square each of these individual things. Okay, so now I have something that is substitutable. I have an r squared and nothing else. So instead of r squared, I can now write x squared plus y squared. And this is my rectangular form for a circle centered at the origin with a radius of 5. Okay, so that one is done. I no longer have any r's, I just have x's and y's, and that's a circle. So then let's look at this one down here, part C. Now I have a cosine. Okay, and I have to find a way to get rid of cosine. So remember over here, I can replace cosine if it has an r in front of it. And I can do that with multiplication. As long as I multiply both sides by the same thing, I'm not really changing my equation. So when I multiply both sides by r, that gives me an r squared, and that gives me 8 times r cosines of theta. Okay, so now I have something that is replaceable. R cosine theta I can replace with the letter x, with the variable x. But also on this side, I also have something that's replaceable. So multiplying both sides by r has now taken care of all of my polar values. So I no longer have any r's, nor do I have any cosines. Okay, so we can write this in general form by bringing the 8x over here to the side with the other variables and setting it equal to 0. So this is the general form for any conic equation. In fact, this one would graph to a circle with a radius, let's see, that was probably before, of a radius of 4 centered at 0, or 4, 0. Okay, when you complete the square, that's what you would get. But this is perfectly fine. So let's move over here. Here we have r equals 2 cosecant of theta. Okay, now cosecant is not something that I want to have. None of my equations are replaceable. So I'm going to instead do a trigonometric substitution. Cosecant is equal to 1 over sine. Okay, so there's no substitutions with cosecants, but there is a substitution with sine. So we replace cosecant with 1 over sine. And now we go to solve this. So we simplify by multiplying both sides. So on the left, now I have r sine theta equals 2. And now I have something that's replaceable. R sine theta can be replaced with y. So this becomes the equation y equals 2, which is a horizontal line. Okay, and then part D, This is a circle equation with a radius of 25, centered at the origin. So once again, I'm going to square both sides so that I get r squared, and I can replace r squared. So r squared gets replaced with x squared plus y squared, and that leaves us with this radius of 25 over on that side. So remember, when you're converting from a polar equation to a rectangular equation, we are looking to make r squareds or r cosines or r sines to replace them with their rectangular equivalent.